Good morning, first and foremost. Before we start, I would like to answer or ask all of you a question. So, except for my colleagues, of course. By show of hands, how many of you already know who I am? Nobody? 1, 2, 3? I'm a little bit surprised. It's my first time on stage, so I'm also a little bit worried how you know me, really. So, okay. But in all seriousness, let's talk about something that we all know, data. Data is the backbone of everything we do online. But there's a dilemma. In Web 2, data is easy. You go to a cloud provider, you launch a database, and it just works. But there's a trade-off. Your data is living on someone else's server. This means you face lock-in, you lose ownership of your data, and you risk censorship. On the other hand, we have Web 3. Web 3 promotes things like ownership of your data, verifiability, and decentralization. But the moment you need to handle complex data, data that changes often, becomes slow, clunky, and expensive. So, until now, we've been forced to choose between either convenience or control. But what if we didn't have to choose between either? What if we could have both convenience and control? Well, that's what we built Golem DB to achieve. Golem DB combines the best of Web 2 and Web 3 into one single place. Let's talk a little bit about the architecture of Golem DB. We have 3 layers. At layer 1, we have Ethereum. It's the foundation of security and finality. At layer 2, we have Golem DB. This is our traffic controller. It's coordinating everything, anchoring to Ethereum, and making sure that our system stays verifiable. On layer 3, we're introducing something completely new, DB chains, or database chains. These are customizable blockchains tailored exactly for your data needs. They look and feel like a database, and you can create, read, update, and delete, but with the guarantees of Web 3. And here's the difference. In most blockchains, data is just raw storage, tucked away as blobs or call data. But in Golem DB, data can be structured, it's searchable, and it's time-aware. So that means you can define how long the data should live on the blockchain. It could be a week, a month, or a year. And what this enables is basically to have an efficient blockchain that cleans itself up automatically over time. So let's put it into some analogy and examples just so you could get a picture in your head. So at the top, we have Ethereum. This is our bedrock. It's the solid and secure foundation. On top of it sits Golem DB. You can imagine it as a global logistics hub. It's responsible for coordinating everything. It doesn't hold the good itself, but it manages to flow and makes sure that everything stays verifiable. Connected to this hub are specialized warehouses, or what we refer to as DB chains. Each one is tailored for a specific job. And to put it into some real-world examples for you guys, you all bought tickets to be here today. Now, imagine a warehouse specialized in ticketing. It can issue tickets, it can transfer ownership when they're sold, and it can automatically expire them once the event is over. Another example could be, let's say, Airbnb. You probably all know about it, or at least the concept of how it works. Someone lists their apartment and another person pays to rent it. Now, imagine that same model, but instead of apartments, it's computing power. That's what we're doing with Golem Network. With Golem Network, anyone like you and I, we can rent out our CPUs and GPUs, and another person pays to rent them. Of course, in order for this to be possible, we need some place to store the data. And this is where our warehouse DB chain comes into place. So here we will be storing everything related to our offers that contains things like our specs for the nodes, the prices, and so on, what's needed for the network to work. Now, it's important to state that you don't need to reinvent the wheel every single time that you need to store data. You can also just use a generic all-purpose DB chain with a SQL engine underneath. So here you can store things like for your everyday applications. It could be anything ranging from collaborative tools or data for your dashboards, you name it. But the beautiful thing is that you're not limited to any of these examples. It's very customizable, and it's customizable exactly to your data needs. So what does this unlock? It means developers get the simplicity of databases from Web 2, but with the guarantees of Web 3. Data that manages itself, storage costs that stays under control, and applications that can finally run in real time. Because with Golem DB, you don't just query data. Through WebSockets, your app can subscribe to changes as they happen. It means you get instant awareness of new creations, updates, or explorations on the chain. There's no waiting, there's no polling, there's just live data flowing into your system, enabling your application to become truly real-time. Another great thing about it is that you don't need to take care of DevOps. Everything you need to get started with Golem DB is your browser. You don't need to host the database or anything itself if you're using a DB chain that's already existing. So just a browser and you can instantly query it. That's it. And that's essentially the promise of Golem DB. We built it on the vision that data autonomy should be the norm, not the exception. It empowers developers and users with control over their data while still keeping the simplicity of normal Web 2 databases and everything they already know ahead. So, thank you very much. And now I would like to hand it over to Dragan for the technical slides or details of Golem DB. So please give him a round of applause.
Thank you, Philip. Before I continue, please give a round of applause for Philip, because this is the first time that he did public speaking. I think he did extraordinarily well. Also, if you have any questions that you kind of can think of while I'm talking, there is a QR code for the questions app that we have. You can submit them there. All right, so what is the Golem DB, or what are we doing there? What is the difference to Ethereum or Optimism or something like that? Well, we have introduced something that we called entities. So entities are data that you can store. They have a couple of things attached to them. So each entity has data, which is any kind of sequence of bytes. It also has a unique ID that is kind of unique throughout the life cycle of the entity, and it doesn't repeat again. There is an expiration. So each entity has finite lifetime. Unlike in Ethereum, where once you store the data, unless you go and delete the data hangs around forever. It doesn't matter if you need it or not. And also there are some annotations. Those are like attributes that you can attach to your entities, and we use them to index the data and to query by. So this is on the kind of storage side, and on the queries, we have custom query language that you can use to select those entities based on the annotations. So how is this coming into the database or into the blockchain to begin with? So it is working very simple. It has a usual Ethereum transaction, but it is changed or encoded differently. It's RLP encoded. It has a list of creates, updates, deletes, and extensions of the lifetime of the entities. Every transaction yields, as the name says, transaction. So if any of those operations within the transaction fails, the whole transaction fails, and no changes are made on the blockchain. And if it fails, it will be marked as a failed. Nothing will happen. If the transaction succeeds, the transaction will emit logs. So in the receipt, you will find the logs, and in the logs, you will find all sorts of useful information. For example, when you create an entity, what is the ID of the entity? If you update the entity, what's the new expiry of the entity. If you're deleting entities, you will get which ones got deleted, and you will also get, if you extend the expiry of the entity, how long they will live. So what is kind of the life cycle of an entity? So an entity gets created at some point. The creator of the entity is the owner of the entity, and the entity gets assigned an ID. So technically, the ID is derived from the transaction hash and position in the array, so it's quite unique. The expiration is defined at the creation time. That expiration is how many blocks will this entity live within the whole thing. The owner of the entity can decide to delete the entity before the expiration, so there is an operation for that, or even extend the lifetime of the entity. But if the owner does not do anything, when the block arrives where the entity has defined expiry, that entity will be automatically deleted. So we are piggybacking our blockchain on top of Optimism, so we are actually going for the deposit transaction that is there in every block, and before that transaction is being processed, we delete the entities and emit the logs, and then process the transaction. So that's how that works. About the query language is kind of matching of the attributes to their values. We support equals, greater than, lower than. We support strings and numeric values. And we also have Boolean logic around it. So you can create any type of Boolean expression that can be quite complex. Our engine can handle that without any issues. And what you get is the list of entities that are being matched. Sorry, I'll have to go one slide back. So can I give it a spin? So yes, of course, you can give it a spin. We have created a test network just for this occasion. So it's on ETHWarsaw, Holaski, golemdb.io. There is also the QR code that will also, before it leads you to this URL, it will also lead you to quick start guides. Within 15 minutes, you should be able to, using TypeScript or Python, create entities and delete entities and every other operation. So it's kind of full-fledged network there. In theory, you can also run your local nodes with Docker Compose. If you really want to do that, please talk to me after. I'll point you to where those Compose files are. So, yeah, talk is cheap, but here is the code. So this is a snippet of the Python code that creates an entity, and you would think, wow, this is a lot of code. But if you take a look at where actually the creation is happening, that is only here. And the rest is just boilerplate Python, setting up the client, getting the wallet, and importing all the packages that are being used. So it's actually quite easy to use. About the tokenomics. So I mentioned that you pay for storing the data. You pay it as a part of a transaction. It is a gas payment, and you pay it for time times space. That means the longer the data should live in the blockchain, the more you will pay. The bigger the data is, more you will pay. On our Golem DB mainnet, the payments will be happening in Golem tokens. And we can set the price of basically how much you will be paying for that time space. And it can depend on the use case. We can spin up different networks for different use cases. If there is a network that someone would like to subsidize most of the cost, we can also arrange for that. So it gives us a lot of flexibility. And we will also have a burn mechanism where we'll be burning both ETH and GLM on the mainnet to be in line with kind of deflationary idea of Ethereum. And because we have all of that flexibility, we control the prices of the storage of the data and so on. We are way cheaper than storing the kind of data on Ethereum, which is not a very high order, because at the moment, the last time I kind of ran the experiment, it was about 0.75 ETH to store 1 megabyte of data. It's forever, but do you really want to store your data forever? We also already have some sample applications that are running on top of our test networks. For example, status page. That is a funny thing about decentralized protocols and so on. Most of them actually have a status page that is on a centralized service. So we have managed to kind of have a status page data being stored on decentralized store and being publicly available for everyone to query. There are also some marketplaces. For example, for the weather challenge, we have a decentralized marketplace where the players of the game can exchange their items on our DB chain. And the metadata for the reality metaverse, for the metadata for the NFTs, also are being stored on DB chains. We also have a little bit of tooling to help you out when you're developing and when you're debugging things. We have a block explorer. It has been changed by Netty. And the block explorer not only supports the usual suspects of looking at the blocks, transactions, and so on. It is aware of the entities. It is able to create entities. It is able to give you the information about the entities, and so on. Now, I mentioned that we are building on top of Optimism stack at this point. This kind of brings a couple of limitations with it. One of them is the maximum transaction size at this point is 120 kilobytes. If you would like to have an entity that is bigger than that, that's kind of impossible because the transaction has to contain the whole entity. We are working on alleviating that, and we can increase the limit and so on. I will give more details later. With the queries, there are no joins, no aggregations at the moment, so you will just get all the data that has been matched. And this is very inherent to Ethereum. At this point, there is no sharding. So each node has a complete copy of the data. So you're limited by how much each node can have on disk and CPU and memory, and you cannot scale past that. And there is the throughput limiting factors. So in Optimism, you have a central sequencer that needs to see all the transactions before it puts them into a block. So there is a delay between transaction pool gossiping and sequencer getting the transaction. And even more importantly, blocks in general are just a sequential execution of transactions, which is the bottleneck if you have a lot of block transactions to process. So now the outlook. So what are we planning to improve here? So first of all, with the query language, we are going to make it a little bit more SQL-like, just to make it easier for people, which is most of the developers aware of SQL, being able to write the queries more easier. And also we will add aggregations so that you can get the count of things or the sums and whatever else you would like to have. And there is, of course, the moonshot. Now, we have been kind of riding on top of Optimism so far, but at some point, given the limitations of it, we have to leave that. So we will probably redesign the whole network mechanics, so how the network works, how the transactions are being processed, passed around, and so on. But it's all to be defined. At this point, we don't have a kind of solid vision of how to do it. The idea is to still be Ethereum aligned. So on the RPC level, this will still be kind of Ethereum network. So you will be submitting your transactions as usual. You will be using RPC to query data. That won't change. And probably using zero knowledge for immediate finality will help a lot, because in Optimism there is kind of a contention window where you could contest the state of the blockchain, and that is a little bit inconvenient. And we might even figure out how to add sharding, because the way that we have designed the entities and everything else, that lends itself to being able to shard. So if we put a bit more effort in it, we might be able to kind of shard across the nodes. And we will be driving this with improvement proposals. So we will start driving the development ourselves with improvement proposals, and we will open to the community to also submit improvement proposals and to drive the development of this. So, join us. Unfortunately, the slide went really awful. We are having a workshop that is starting tomorrow at 11 about how to use Golem DB and how to use the SDKs. Christoph will be being the speaker and leading the whole thing. We'll be also giving special prizes, like these Web3 Pies. It's also a project of Golem, which is a very efficient way of running an Ethereum node, because it's everything that it needs to run Ethereum node, all the storage, all the CPU, and so on in a very small package, and it's very power efficient. Also, we will be starting a Capture the Flag competition tomorrow. Please follow our socials about that. There will be prizes for Capture the Flag, and there will be a hackathon also starting tomorrow, as far as I know. And we have $6,000 prize pool for the hackathon. So if you're interested, you can take part and maybe win some of the prizes. Also, we'll be having a talk tomorrow about the Web3 Pies. Peter will be doing that tomorrow, and I think it is 1:30. Now, about the rewards that we are kind of giving out. So for the hackathon, I've mentioned $6,000. First prize gets $3,000, second place $2,000, the third one $1,000. Also for the other participants, there will be also some Web3 Pies being given away. We also have GLM tokens to give away that will be part of the prizes. And also the Vanity Market vouchers, which is basically having your Ethereum addresses looking nicer, so not being just garbled random characters, but you can define what is the prefix and the suffix of the Ethereum address and so on. So, and we have the Golem Ecosystem Fund, which will give up to $100,000 for selected projects. For example, if some projects from the hackathon would like to continue and so on, we could fund that. So last but not least, follow us on our socials. So we are on X, on Discord. And I think we can start with the questions. And
space for, we have some space for the questions. So anybody looking to ask something?
Yep.
We have number one.
So first we will start with those.
You outsmarted me. I'm sorry.
So we had this app for the questions. So exactly what search primitives there are for entities? Consider them to engineer's perspective. Can I arrange queries? Do range queries? String prefix, suffix contains. Can extensions be added to say, I would like to implement my own indices search, such I could, okay. Basically, most of that. So we definitely range queries we have, string prefix we have, and suffix too. And at the moment, well, we are open source. You can take a look. We didn't put any kind of plugin system behind it, but you can kind of hijack on all of this. I can give you kind of heads up. We are storing the state, a copy of the state in the local SQLite where we're doing queries. So you can just open that SQLite and query there. Second question, is it a solution for enterprises, single users, developers, accountants? So who could be the customer? That is a very good question. The customer is kind of defined by the kind of constraints of what we are doing. So consider every Golem DB a public database. So everyone can have a copy of it, and everyone can have access to it. And it's fully replicated, and way better replicated than any other database you would find. So if your data fits that is probably a good fit. If you have tons of data, like terabytes of data and so on, at this point I would not choose Golem DB for that because we have no sharding. We cannot provide it unless you run nodes that run terabytes of disks. Data storing for limited time. What about local laws? No telecoms need to provide to law enforcement of calls, movement. So the information is not erased. It is a public blockchain. All the transactions are known to everyone. Even if the data has been deleted in the state of on the node, there is still a record within the transaction that data was created. I don't think that you cannot trace the calls, movements, and so on because the transactions are being gossiped over the peer-to-peer network, so it's really difficult to trace all of that. But that applies, like all the mechanics and all the limitations that are applying to an Ethereum network apply to us. Anyway, so I would like to make a break here and ask actually Maciej to show what we have done here with those questions, because all of those questions we have put into a database, so Golem DB. So this is the explorer that we have, and you can see the questions. So we're a little bit dog feeding our own solution right now.
Amazing solution to solve endless questions from the audience. Guys, thank you so much for the time today. We need to wrap up, but huge applause for Golem. Thank you, Dragan, so much for the insights. Thanks, Phillip.
Thank you very much.